1984. Deep inside a classified Navy facility in San Francisco Bay, engineers were building something that wasn't supposed to exist. A warship. But not just any warship. This ship was designed to be invisible. Not to the human eye, to radar. A stealth vessel that could sail into enemy harbours undetected, conduct covert operations, and vanish without a trace. The technology was revolutionary. The design looked like it came from a science fiction movie. The budget was essentially unlimited. $3 billion. Adjusted for inflation, that's over $7 billion in today's money. The most expensive experimental naval vessel in American history. It took 7 years to build, another 15 years to test, and in all that time, it had exactly one job. Don't sink. It couldn't even do that. On its first mission in actual ocean conditions, not a calm protected bay, but real open water with real waves, the Sea Shadow nearly capsized. The crew described it as fundamentally unsafe in any conditions above light chop. Light chop. That's maritime code for barely any waves. The kind of conditions a recreational fishing boat handles every single weekend without problems. The $3 billion stealth warship couldn't handle what a bass boat handles routinely. This is the story of the Sea Shadow, the invisible warship that the Navy spent 2 decades pretending worked and eventually scrapped for the price of a used car. The concept started in the late 1970s, at the height of Cold War paranoia. The Soviet Union had submarines everywhere. Their navy was massive, aggressive, and technologically sophisticated. American naval intelligence was stretched thin, trying to track Soviet movements. Traditional surveillance methods weren't working. Surface ships were too obvious. Submarines were effective, but couldn't operate in shallow coastal waters, where much of the Soviet activity happened. The Navy needed something new, something that could get close without being detected, something that could conduct reconnaissance, insert special operations teams, and extract intelligence assets from hostile waters without anyone knowing it was there. Around the same time, the Air Force was developing the F-117 Nighthawk, the first operational stealth aircraft. The technology was proving revolutionary. Radar systems that cost millions of dollars couldn't detect a plane that was right in front of them. Someone in naval intelligence had an idea. If stealth worked for aircraft, why not ships? The problem with ships is fundamental geometry. Aircraft are small, fast, and can be designed with complex curves that scatter radar waves in all directions. Ships are enormous, slow, and traditionally built with large flat surfaces that reflect radar like mirrors. Every angle on a conventional warship is optimized for one thing: functionality. Antennas, railings, weapons systems, superstructures, all of it sticks up, out, and proud. Perfect for crew operations. Perfect for radar detection. To make a ship stealthy, you'd have to redesign everything from the ground up. Eliminate curves, hide protrusions, angle every surface to deflect radar away from its source rather than reflecting it back. It would look bizarre. It would be expensive. It might not even be seaworthy. The Navy decided to try anyway. In 1981, Lockheed's famed Skunk Works division, the same people designing the F-117, received a classified contract. Build a stealth ship. Make it invisible to radar. Prove the concept works. Budget constraints. There weren't any. This was a black program. Congressional oversight was minimal. The Navy essentially wrote them a blank check and said, "Make it happen." Lockheed's engineers started with a clean sheet. They studied the F-117's faceted design, all sharp angles and flat panels. They applied the same principle to a ship hull. The result looked like nothing that had ever floated. Traditional ships have smooth, rounded hulls that cut through water efficiently. The Sea Shadow had flat, geometric facets arranged at precise angles, like a diamond, or a stealth fighter turned inside out. Traditional ships have superstructures rising above the deck, bridges, communication towers, weapons mounts. The Sea Shadow had almost nothing above its waterline. The crew compartment was a recessed, angular box, barely visible. Traditional ships sit in the water with a single hull. The Sea Shadow used ASWATH design. Small waterplane area twin hull. 2 submerged pontoons, like a catamaran, with the main cabin suspended between them on struts. The idea was to minimize the ship's profile, both above and below the waterline. From the surface, radar would see almost nothing. From below, sonar would have trouble tracking the submerged pontoons. On paper, it was brilliant. Every design choice optimized for one thing: stealth. Unfortunately, every design choice also made the ship fundamentally unstable. Construction began in 1984 at Lockheed's Redwood City facility in California. The entire project was classified. Workers signed non-disclosure agreements. Security was tighter than most military bases. The ship was being built inside a massive covered barge, a floating dry dock called the Hughes Mining Barge, so that satellites and reconnaissance aircraft couldn't photograph it. Even the materials were exotic. The hull wasn't traditional steel. It was composite materials, designed to absorb radar waves rather than reflect them. Special coatings covered every surface. The paint alone cost more than most naval vessels' entire construction budgets. Every component was custom designed. There were no off-the-shelf parts. No existing equipment fit the bizarre angular design. Engines, generators, navigation systems, everything had to be modified or built from scratch. The ship's dimensions were unusual by design. It was small for a military vessel, only 160 feet long, but it sat high on its pontoons, making it appear larger from certain angles while remaining low profile from others. The crew capacity was tiny, 12 people maximum, cramped quarters, minimal amenities. This wasn't designed for comfort or long-duration missions. It was a pure technology demonstrator. Initial budget estimates put construction costs at $200 million. By the time the Sea Shadow was completed in 1986, costs had exceeded $1.2 billion, and they hadn't even tested it yet. The first tests were conducted entirely inside the Hughes mining barge. The barge could be partially flooded, allowing the Sea Shadow to float while remaining hidden from outside observation. Engineers measured radar cross-sections using specialized equipment mounted around the barge's interior. They tested the stealth coatings. They calibrated systems. They ran the engines. Everything worked. The radar signature was microscopic, smaller than a fishing boat, despite the Sea Shadow being the size of a small warship. The stealth technology was proving even more effective than the F-17s. The Navy was thrilled. This was going to revolutionize naval warfare. There was just one problem nobody had adequately tested. Could it actually sail in the ocean? The Sea Shadow's first open-water tests were conducted in San Francisco Bay. At night, in perfectly calm conditions, with a support vessel standing by. It floated. That was a good start. It moved under its own power. Also good. But it moved wrong. Traditional ships have what's called sea-kindly motion. They roll gently with waves. They pitch slightly in swells. The motion is predictable, manageable, something crews get used to. The Sea Shadow's motion was violent and unpredictable. Because of its flat-faceted hull and SWATH design, waves hit the pontoons at odd angles. Instead of rolling smoothly, the ship would lurch. It would suddenly tilt 10 or 15 degrees without warning when a swell hit just wrong. Crews reported feeling seasick even in calm water. The cabin would shift and bob in ways that seemed unnatural. It felt, according to one sailor, like standing on a floating brick that's trying to decide whether to tip over. But these were just calm water tests in a protected bay. The Navy figured it would be fine in actual operation. They were spectacularly wrong. 1993, merely a decade after construction began, 7 years after completion, the Sea Shadow had been operating exclusively in San Francisco Bay, essentially a very large, very calm lake. The Navy decided it was time. Take it out into the Pacific, conduct realistic operational tests, see how the stealth ship performed in actual ocean conditions. Weather forecasts predicted mild conditions, seas at state 2 or 3, gentle to moderate swells, light winds, about as good as conditions get in the Pacific. The mission was simple. Sail 20 miles out, conduct radar profile testing with aircraft flying overhead, return to base. Total duration, 8 hours. The Sea Shadow departed before dawn, escorted by 2 support vessels. The crew consisted of 10 sailors and 2 engineers. Everyone aboard was excited. This was finally the real thing. No more bay training, actual open ocean operations. Within 30 minutes of leaving the Golden Gate Bridge, problems started. The first ocean swells hit the pontoons at an angle the designers hadn't adequately accounted for. The Sea Shadow lurched hard to port, left, tilting nearly 20 degrees. 20 degrees is severe. At that angle, unsecured items slide, people lose balance. It feels like the ship is capsizing. The crew scrambled for handholds. One engineer slammed into a console. Coffee mugs and equipment crashed to the floor. Then, just as suddenly, the ship righted itself, swung back past level, and tilted 15 degrees the other direction. This wasn't normal ship motion. This was oscillation. The Sea Shadow was rocking like a metronome, amplifying each wave's impact rather than dampening it. The captain immediately reduced speed. That helped, slightly. At lower speeds, the oscillations were less violent, but still present. They tried changing course. That made things worse. Certain headings relative to the swells caused even more extreme tilting. After 90 minutes of this, with half the crew actively seasick and the engineers frantically checking systems to make sure nothing was damaged, the captain made a decision. Abort the mission. Return to base. They limped back to San Francisco Bay at reduced speed, taking nearly 4 hours to cover the 20 miles back. Every swell was a gamble. Every course change risked capsizing. When they finally reached calm water, multiple crew members needed medical attention for injuries sustained during the violent rolling. One sailor had a suspected concussion from being thrown into a bulkhead. The post-mission report was damning. The Sea Shadow was, in the captain's words, fundamentally unsuitable for open ocean operations in any conditions above Sea State 2. Sea State 2 is defined as smooth to slight waves, wavelength 10 to 20 feet. The kind of conditions you'd take a sailboat out in without concern. The $3 billion stealth warship had failed in what a weekend sailor's boat handles routinely. The Navy had invested a decade and billions of dollars. They had a ship that was invisible to radar, but couldn't go anywhere with waves. They had three options. Option 1, admit the design was fundamentally flawed, scrap the ship, accept the loss, face congressional oversight and public embarrassment. Option 2, attempt a redesign, spend more years and more billions trying to fix the stability problems while maintaining stealth characteristics. Option 3, pretend everything was fine, keep the ship operational in calm waters only, continue the testing program indefinitely, eventually claim success and quietly retire the vessel. They chose option 3. For the next 13 years, the Sea Shadow remained operational. Sort of. It conducted regular missions in San Francisco Bay. Media was occasionally allowed to photograph it from a distance. The Navy published papers about its revolutionary stealth technology. Everything they said about the stealth capabilities was true. The radar cross-section really was microscopic. The technology really did work. What they didn't mention was that the ship couldn't leave protected waters without risking catastrophic stability problems. When asked about deployment timelines, Navy spokespeople would give vague answers. The Sea Shadow is a technology demonstrator. Operational deployment isn't the primary objective. Or, the program has met its research goals. Translation: it doesn't work, but we're not admitting it. Internally, the program became a joke. Crews assigned to the Sea Shadow called it the Death Trap, or the billion-dollar barge. SEALs who trained on it for insertion exercises said they'd rather swim than trust their lives to that ship in real operations. One former crew member, interviewed years after the program ended, was blunt. Everyone knew it was garbage. It looked cool, the stealth tech was real, but as an actual warship, useless. We'd train in the bay, run scenarios, and everyone knew if we ever had to use this thing for real, we'd be swimming home. Another sailor described a training exercise where they simulated inserting a SEAL team near a hostile coast. We practiced it in calm water with the boat anchored. Nobody even suggested trying it with the engines running in realistic sea conditions. We all knew what would happen. But the program continued. Budget allocations kept flowing. Congressional reports listed the Sea Shadow as an active research platform. Media coverage, when it happened, was carefully controlled. The Navy even considered building a second, improved version. Design studies were conducted. Engineers proposed modifications that might improve stability while maintaining stealth. The cost estimates came back. Another $2 to $3 billion. With no guarantee the problems would be solved, that idea was quietly shelved. 2006, 22 years after construction began, 20 years after completion, 15 years after the failed open ocean test, the Navy announced the Sea Shadow program was being terminated. The official statement was carefully worded. The Sea Shadow served as a successful technology demonstrator. The stealth technologies developed through this program have informed current and future naval vessel designs. Having completed its research mission, the vessel will be retired. Translation: it never worked. We're done pretending and we're getting rid of it. The Navy's first plan was donation. Offer the Sea Shadow to a maritime museum. Let it become an educational exhibit about Cold War technology and naval innovation. Multiple museums were contacted. All of them declined. The reasons were consistent. The ship was too large to display properly, too expensive to maintain, too classified. Even after declassification, certain systems and materials remained restricted and too dangerous to have near public spaces given its stability issues. One museum director was blunt in his rejection. We'd essentially be displaying a $3 billion admission that the Navy wasted taxpayer money. Nobody wants that exhibit. With donation impossible, the Navy tried to sell it. Perhaps a private collector, a defense contractor wanting to study the technology, or a foreign government interested in stealth research. No buyers. The stealth coatings were obsolete by 2006. The design was proven unsafe. The hull materials were specialized and difficult to maintain. Nobody wanted it. That left one option: scrap it. The Navy sold the Sea Shadow to a demolition company. The sale price was $2,500. $2,500 for a vessel that cost $3 billion to build. The demolition contract specified that all stealth materials and coatings had to be destroyed rather than recycled. Can't risk that technology falling into foreign hands. So in 2011, the Sea Shadow was cut apart. The revolutionary stealth coatings were stripped off and incinerated. The composite materials were shredded. The hull was reduced to scrap metal and sold by weight. The most expensive experimental warship in naval history became rebar and recycled aluminum. Today, almost nothing remains of the Sea Shadow program, except declassified documents and a few photographs. The Hughes mining barge that housed it during construction was also scrapped. The technologies developed? They weren't wasted entirely. Modern stealth ships like the Zumwalt-class destroyers use similar angled hull concepts, but they're also massive, stable platforms that can actually handle ocean conditions. The lesson learned was expensive but clear. You can't prioritize stealth over basic seaworthiness. A ship that can't sail isn't a ship. It's a very expensive floating object. The Navy never built another Sea Shadow. The program's failures were classified for years. By the time documents were declassified, most people had forgotten it existed. $3 billion. 22 years. Countless engineering hours. And the legacy is a pile of scrap metal and a cautionary tale about what happens when you design a ship that can't handle waves.